Choosing the number of clusters. Like any learning method, clustering also has its knob to adjust the complexity. It is k, the number of clusters. Given any k, clustering will always find k centers, whether they really are meaningful groups or whether they are imposed by the method we use. There are various ways we can use to fine-tune k. In some applications, such as color quantization, k is defined by the application. Figure 7.5 is a two-dimensional dataset and the dendrogram showing the result of single-link clustering is shown. Note that leaves of the tree are ordered so that no branches cross, and the tree is then intersected at a desired value of h to get the clusters. Okay, plotting the data in two dimensions using PCA may be used in covering the structure of data and the number of clusters in the data. An incremental approach may also help. Setting a maximum allowed distance is equivalent to setting a maximum allowed reconstruction error per instance. In some applications, validation of the groups can be done manually by checking whether clusters actually code meaningful groups of the data. For example, in a data mining application, application experts may do this check. In a color quantization, we may inspect the image visually to check its quality, despite the fact that our eyes and brain do not analyze an image pixel by pixel. Depending on what type of clustering method we use, we can plot the reconstruction error or log likelihood as a function of k and look for the elbow. After a large enough k, the algorithm will start dividing groups, in which case there will not be a large decrease in the reconstruction error or large increase in the log likelihood. Similarly, in a hierarchical clustering, by looking at the differences between levels in the tree, we can decide on a good split. Note that mixture models are frequently used in statistics. Dedicated textbooks are those by Titterington, Smith, and Makoff, and McLaughlin and Basford. McLaughlin and Krishnan discuss recent developments in the EM algorithms, how its convergence can be accelerated, and various variants. In signal processing, k-means called the Lindy-Buzzo-Gray LBG algorithm. It is frequently used in both statistics and signal processing in a large variety of applications and has many variants, one of which is a fuzzy k-means. The fuzzy membership of an input to a component is also a number between 0 and 1. Gapheiding compares k-means, fuzzy k-means, and EM on Gaussian mixtures. A comparison of EM and other learning algorithms for the learning Gaussian mixture models is given by Zhu and Jordan on small data samples. An alternative or simplifying assumptions is to use a Bayesian approach. Moreland compares mixtures of Gaussians and mixtures of latent variable models on a set of classification problems, showing the advantage of latent variable models empirically. A book on clustering methods is by Jane and Dubis, and the survey articles are by Jane Murty and Flynn, and Zhu and Wunsch in 2005.